So in this question we're asked to look at a ball bouncing off a smooth plane, and we're told that the velocity before the impact is ui minus vj. Now we need to be really careful here because this is not the way that we usually use u and v in these questions. We're used to them being the initial velocity and the final velocity, but that's not what they are in this case. U is the velocity in the x direction and v is velocity in the j direction. What we're trying to do is find the velocity of the ball after the collision in terms of u and v, and e, which is the coefficient of restitution. So we start with the before diagram. We know that the velocity before the impact is ui's minus vj's. So we can mark those quantities u and v onto our diagram. U in the positive x direction, if you like, and v going negatively in the y direction. Now, after the collision, there are a couple of things we need to remember. Firstly, we need to remember that the coefficient of restitution has no impact in the horizontal direction here, but it does have an impact in the vertical direction here. So in the I direction, the velocity doesn't change, it remains just u. But in the j direction, the coefficient of restitution comes into play, and it's going to be e times v. Remember, e is between 0 and 1, so this is a reduction in the size of v. So the answer to the first part of the question is ui plus evj. The negative has become a positive because of the change in direction. Now we're also asked to show that tan beta is equal to E times tan alpha. And this is fairly straightforward to do once we realise what tan of alpha and tan of beta actually are. Tan of alpha, well, tan is opposite over adjacent, so it's just V over U in our diagram. Tan of beta, similarly, opposite over adjacent, is EV over U. We can actually rewrite that as E multiplied by V over U. But we know what V over U is. That comes from our first diagram. V over U is equal to tan alpha. So tan beta is just equal to E times tan of alpha.